Hi, and welcome to yet another video in AI and C#. Today we are going to look at semantic kernel and Microsoft Extension AI once again. I have a previous video where we talked more high level, concept based and so on, what the differences between the two were. And a short version of that is that Microsoft Extension AI is a low level version of, and then we have semantic kernel who can do more advanced stuff. But let's talk about semantic kernel going into maintenance mode and being replaced by something else. There's always this, oh, can I just use Microsoft Extension AI? So in this video, we're gonna go actually to see how to do all the common stuff that you need to do as code. And then you can take your decision on that, and you can use it as a reference guide for in my AI sample repo to actually understand if you are needing to migrate one way or the other. So what we're going to look at is we're going to look at what NuGet packages are needed for both of them, what dependency injection options there are, and what on-the-fly setup options there are if you can't use or don't want to use dependency injection. Then we have chat, basic and streaming chats, function calling, and structured output. Then we have RAG, meaning embeddings and vector stores. And then we have put in another, which is more or less agents integrating into AI Foundry and storing threads on various agents and so on. So let's jump into Visual Studio here and have a look. And this is just a new console app I have in my AI samples that you can find online. And let's first look at the NuGet packages I have here. The first three up here is the ones that are needed for Microsoft Extension AI. If you only have this, you only get the objects, but you can't connect to any LLM. So in order to do that, you need the extension, so you can get the iText client, and you need the Azure OpenAI by itself. If you want to go semantic kernel, you can more or less just take this, and you can do exactly the same as the three other packages you have up here, mostly because this package include OpenAI by default. There's a few other packages if you need some of the more optional things that semantic kernel can do that Extension AI can't do. But this one package from semantic kernel can do exactly as the same as the package up here. So it's a little easier to set up. And let's then look at it. First up, I have some stuff up here where we can set up various configurations. So these are just my credentials and endpoints and so on. We're going to use the ChatGPT 5 Nano model here because we're not really caring about the AI responses today. It's more how you react to them, so we don't need to have the big, great model. And we need embedding models where we're just using the embedding tree small model. I've then put in a HTTP client because if we are going with reasoning models, the default 100-second timeout in HTTP client might not be enough if you need to do reasoning. So I've just put in how you actually set up a 5-minute timeout or more. Then I made an enum just so I can switch if you run this code and have semantic kernel do the work or Microsoft Extensions AI do the work. We're not going to run the code today. Do that on your own. That's not the point here. It's more how it actually looks and what the different things is. As this is an AI or a console app, I've just put in the host application builder so we can do dependency injection in a console app. And if we look at dependency injection, if we look at Microsoft Extensions AI, the way you do it is that you actually take the raw package of your LLM, in this case Azure OpenAI client, and set that up with your endpoints, keys, and in this case the HTTP client. And then you register two things, an chat client and an embedding client. And because this is the raw thing that doesn't know anything about Extensions AI, we have these as iChat client and as iEmbedding client. And if we look into these, you can see these are the ones that are part of the Microsoft Extensions AI, and in this specific case, it's part of the OpenAI underlying model. So this is the reason why we can do this. So it turns into this more generic thing. And the same for iEmbedding generator. So fairly simple, a little clunky to figure out that you actually need the raw before you can work with it. For semantic kernel, for comparison, it is much simpler, in my opinion, because we can just say we want an AI chat client and we want an embedding generator. So the same here. You just tell on the fly here what it is because they have their various connectors. But this shouldn't really break anyone one way or the other. It's fairly simple, both of them. On the fly, we can do something similar. If we look at Extensions AI, it's exactly the same code. It's just not dependency injected. And the same goes for the embedding client, where we just get it out as a string embedding float. Semantic kernel can do more or less the same, but they have something called a kernel builder, which is a kind of mini dependency injection that you can have on the fly, which actually can give some benefits, but it's also unknown to many people using dependency injection that you actually have a mini dependency injection that runs on the fly. But it works, and it has the AI chat client and the embedding client, so it's exactly the same way as dependency injection. They have an older version of AI chat completion. I've included it in here because there's currently a bug in one of the features, structured output, where it's actually depending on this. The team from Semantic Kernel are fixing it, so it can also just use this, and we could get rid of this one because this is not really needed anymore. It was something Semantic Kernel had before the Microsoft Extensions AI came along. And I'll explain why that is actually a thing in 1 second. So if we want to have the tools, you just new them up here, while here you can not really new them up, but you instead get them from the kernel, a little like a normal dependency injection. So a little more funky way for semantic kernel if you want to do it on the fly compared to the raw way you do it in Extensions AI. Next up, let's look about the chat. And I've just put in a random question here. And the cool thing about this is that nowadays they can both work exactly the same. So this code is essentially Microsoft Extensions AI. But if you didn't do the dependency injection or on the fly, behind the scenes, semantic kernel works with its own thing, but it's also automatically registering an iChat client, so you can do exactly the same. So this code, no matter if I choose Extensions AI or semantic kernel here, will just work. And this is, again, Microsoft Extensions AI code. Later on, we'll see how you can do it with the flavor that semantic kernel have. But in this case, we just get the iText client. And if you want to have a basic response, we just say get response async. If you want to use reasoning in the new ChatGPT 5 models, it is a little clunky to do with extensions AI. You need to set chat options, and then you need to set some raw representation factory, which is not really a discoverable thing. And in that, you get completion options with reasoning effort. So you can set it. So it can be set, but it's not as elegant as in semantic kernel, which we'll see. Then we get our response back, but we can't from each response get our usage, so we can get our input and output tokens, and we can also get the reasoning tokens. So this is a fairly simple and actually easier than semantic kernel way to get usage. If we need to do streaming, it's just as easy. You can of course put in the usage and the reasoning level here, but else you just do get streaming response. And if you want to use structured output, you just say get a response with an object, in my case just a city and some population data, and then you can just get your result back. This is actually very nice in Microsoft Extensions AI. It's a little more clunky when it comes to semantic kernel, which we'll see. Function calling is also fairly simple, but the main issue, whatever we call it, is that every time you get a response, you need to put it in as chat option what tools are available. You might like that. In semantic kernel, you can register them up front, and then you can use them across all different responses. So that's just a matter of opinion. But function calling is fairly simple. You just create your function as some kind of delegate or and then you can use your tools. So again, all this can be done with both semantic kernel as the setup or as semantic Microsoft Extensions AI as setup. So this is actually not how I use semantic kernel. I will slowly begin to use this, but the reason for that is I tend to use agents. So let's have a look at what we can do with agents in the two frameworks. And for Extensions AI, it's fairly simple in that it doesn't have that concept at all. It has chat and it has embeddings, but beyond that, nothing. So if you want to integrate into AI Foundry, for example, with their agents and their threads up there, you need to grab another NuGet package for AI Foundry or the OpenAI package for their assistants. And or Microsoft Extension AI will not help you here. I haven't written the code, but because that's not what this is about, because in my book, if you need to use agents, you shouldn't use Microsoft Extensions AI. When it comes to semantic kernel, we can do what is called a chat completion agent, where we can go in and tell the kernel, which I set up on the fly here, but I could also have done it using dependency injection. But we set up the agent, and the agent has built-in system messages. We didn't do anything up here with system messages and so on, but that would have been that instead of a question in here, we would have needed to put in a collection of chat messages where the first one would be the system message. So with agents, which is the ones I prefer normally to use. It's all put into the concept of an agent with system prompt and all these things. When it comes to talking with the agent, it's just an invoke agent instead of respond async. And it comes back in these for each loops because they're a little more funky to read out, but that's because it can give multiple things back, which the other ones from Extension AI can't. Getting the users out is a bit more tricky in that it just is inside the metadata and usage. But you can get it out, and this is because the agents can work with multiple systems, some of them which doesn't have usage, or back in the day, usage was not a thing you could get out, so it was packed into some metadata, while now all of them can give usage back, and for that reason, there's a dedicated usage part of the response. But you can get all the same data in here. Same goes for streaming. You can do streaming instead of just a request response. You can do structured output, which is a bit more clunky with agents in that you need to set some execution settings and tell the response format back. Up here, we just gave it as a generic, and it came back with that. Here we need to get it back, and we get it back as JSON, and we need to deserialize it ourselves. Could give some benefit if it's worth for you to get the JSON directly, but I don't really see the case because you need to remember to do string enum converters and stuff. So it's a bit more funky. I've just packed it away in a helper method, but beyond that, it is a bit more clunky to do. Function calling, when we come to that, works more or less the same, but instead you tell the kernel you're working with, which is the agent you work with, what kind of tools there are, and they are decorated with a kernel function, so they can be picked up that way. And then you need to tell how should the function calling be happening. So a bit more work to set them up, but there's much more control. You can just put all your plugins on here, and then you can say this agent have access to these, this agent have access to these. There's interceptors for function calling where you can actually get, it's about to call this function. Do you allow that based on some audit, based on security and so on, which you can't do in Extensions AI. So that is the basic simple agents if you just want to control them on your own. But you can also use the Azure AI agents, which I did in my video about AI Foundry. So they are persistent agents up in Azure. And the same way you can use the OpenAI agents or assistants, as they're called, where you have your sidebar in OpenAI that you can interact with. So again, this concept doesn't exist in Extensions AI, and if you don't need it, then you probably won't need semantic kernel. But I like to have it like this, so I have better control over system methods. I have better control over most of the things in my system. But that's a matter of, do you need agents or do you only need chat completions? The final thing we have is embeddings and vector stores. So embeddings are easy because they both work exactly the same way. Semantic kernel had their own way in the past, but have now adopted extensions AI as a dependency and only being a subset of that. It is possible to just get the required service either from the kernel or the dependency injection and just get your vector float. So you can easily do embedding and get vectors back, no matter if you use one or the other. But then it comes to actually storing that vector somewhere. And if we look at extensions AI, they have nothing in terms of that. You can make the vector, but if you need to store that vector somewhere, you need to grab the Azure AI Search or the Cosmos DB NuGet package or the Quadrant or the VV8 or whatever vector store you want to do, and you work with their packages. When it comes to semantic kernel, they have created something called Microsoft Extensions Vector Data. And as you see in the name, it's about to become something that are not just semantic kernel specific, but the general way for Microsoft to do vector data. So it's an abstraction layer, just like extensions AI and extension.dependency and then injection extensions.logging and so on. But the only ones who are using this new package is the semantic kernel team, because they are the only one who have actually made connectors or integrations to it. And they have various. They have for in-memory, Azure AI Search, Cosmos DB, SQL Server, and so on and so forth. So if you are someone who wants to switch between these, semantic kernel is much easier because you can just write your vector store as I do here. In this case, I'm using the in-memory vector store, but had I used Azure AI Search, I would write Azure AI Search here instead and give in some credentials. Had I used SQL Server, I'll use some other credentials and so on. But these work exactly the same, so you get this generic store that are working across all the different vector stores. And then you can just take your store, make your collection, an index in Azure AI, a table in SQL Server, a table in Cosmos DB, and so on. And then we can begin to create that collection, we can upsert data, and we can search for the data again. And this is completely generic, based on not caring about what vector store you do, while again, up in Microsoft Extensions AI, you need to write your code. You need to new up a Azure AI search client and find the index you want and add data to it. Of course, it can be done, but for semantic kernel, it just have this out-of-the-box feeling compared to this. So as you can see, when it comes to the more advanced stuff, and semantic kernel have more, it has something called a process framework that I actually haven't looked at myself. But in terms of NuGet packages, I would say extensions AI is a bit more clunky because you need to really understand what's going on, while it's just a plug and play for semantic kernel. When it comes to setting them up, more or less the same. A little easier for semantic kernel, but nothing much. On the fly is roughly the same. Might confuse people with the kind of dependency injection in on the fly. Chat, if you just need basic chat, it's exactly the same in both of them. But if you want to go a bit beyond and have agents, semantic kernel is the only offering, and there you can get this nice bundled thing that just works no matter if you needed to connect it to one thing or the other, needed to use it basic. And that's the reason why all the code you have seen from me so far have used these completion agents. Technically not needed. We can just use the iChat client, which have some nice things like structured output are definitely easier to work with, while function calling is a bit easier in the agents, in my opinion. And then we have embeddings, where extensions AI are not that strong. It can make the vector, but if you actually need to work with a vector store, you're on your own, while semantic kernel again gives this higher level abstraction for you to work with. So that is everything I wanted to show. The main point actually here should probably be that there is not that much difference, especially now that semantic kernel have chosen extension AI as a subset for doing the basic stuff, throwing away their old way of doing things themselves back when there was nothing to build upon. But now, once they have that, it doesn't really matter which of them you use, except if you want to do more advanced stuff with agents, vector stores. So if you're just building a chatbot, use extensions AI, probably. But if you want to actually build something that have persistent agents, can do various tool callings and so on, I would still go with semantic kernel and whatever they are coming up with next as well, which is probably gonna be something where they focus even more on these two, because the low-level stuff should not be reinvented. There's no reason to reinvent the wheel on that part. So I hope that made it simpler, and again, use this to say, oh, I need to know how you do this specific thing in semantic kernel versus extensions AI, so you don't need to look up everything yourself. And with that, thank you. See you on the next one.